Hello, in this video we're going to be talking about Math 3, Unit 9, density. So density is something that we haven't always taught in the math department. This is a crossover into our science curriculum, but it has to do with volume. In fact, the formula for density is mass divided by volume. And something very dense then might have a big mass in a small volume. That'd be very dense. And so this is the formula. Some people tell me that the formula looks like a heart. If that helps your students remember that, that's fine. Units are crucial in this. This is going to be a nice review of their Math 1 unit analysis work in this section. And so that's one of the great things as we come up to their SBAC test. So I'm just going to show you a couple examples. There's a worksheet that you're going to do. There are problems in the textbook in section 10.2 that you can use for notes and that they can watch videos on. So if you are a MathXL user, you might want to look at 10.2 for problems for homework. So there's a two-sided worksheet. I haven't run it back to back, so it looks like two pieces of paper here. And I'm going to start with problem number 2 as an example. The cube of steel below has a mass of 3,920 pounds. What's the density of steel? And so I have my cube and I have the mass as 3,920 pounds and we're trying to find the density. So remember that density is equal to the mass divided by the volume. So we have the mass but we do not have the volume. So the volume of this cube is going to be 2 by 2 by 2 or 8 cubic feet, not 6. And then they're going to plug into this formula and get 3,920 pounds divided by 8 feet cubed, 8 cubic feet, and that will end up coming out to 490 pounds per there's no cubed there, pounds per cubic foot. And so 490 pounds per cubic foot. That would be the correct answer. The math is really simple. They need to calculate some volumes to be able to do this, so this will flow nicely from their volume work in 9.1. And then they need to pay attention to the units. So let's talk about when they're not asking for density, when they're asking for one of the others. Number 8, I'll just show you on the paper. It says this cylindrical cake below has a density of 0.285 grams per cubic centimeter. What is the mass of the cake? And so some people like a really dense cake. Some people like a nice, light, fluffy cake. Bakery should advertise, right? So, but this density is 2.85 grams per cubic centimeter. And so here's our cake with the measurements on. Here's the density, and we want the mass. So remember, density is equal to mass divided by volume. This is the thing we want. We're going to plug in. We need to find the volume first. And so the volume of a cylinder is the area of the base times the height, the same as every prism, the same as everything. I would encourage you to not make them have a different formula for every type of two-ended thing, prisms or cylinders. It's always area of the base times the height. And so in this case, the area of the base would be pi r squared. And so 10 squared is 100 pi times the height. These are both in centimeters, so actually it would have been nice if I did it this way. Let's be careful. 10 centimeters squared times 15 centimeters. You can see you will have 100 centimeters squared pi times 15 centimeters, and that will give us 1,500 pi centimeters cubed. So my volume is in centimeters cubed. Just being careful with the units. Now we're going to put that into our density formula, and so the density is 0.285 grams per centimeter cubed, and that's going to equal the mass that we want over our 1,500 pi centimeters cubed. And I'm a little crowded here, and since I have this whole page and I can use it for free, I'm going to go down and do that. And so I'm going to just multiply this over, and as you do this, don't be too lazy to write the units because you really want your students to do that. Here I have the density times the volume, and that's going to equal my mass. Notice these centimeters are canceling out, and I'm going to end up with the mass in grams. When I multiplied these, let's see, I did this one earlier, I got, multiplying in the pi, I got 1343.031 grams is the mass of the, no apostrophe, grams is the mass of the cake. So units are important. Tell them they're going to lose points if they leave off units. The units inform what you're doing. If you know you should be getting a density, you know you shouldn't be getting a fraction. If you know you're getting a mass, it should just be a single unit, and it helps them remember whether they multiply or divide. I just want to show you one interesting problem. I really liked this one. I'm going to show you mine in terrible scratch work because I want to make this video shorter. Let me just zoom in a little bit here and autofocus. So I thought number 11 was such an interesting problem. Oh, darn it, almost forgot. I want to talk to you about population density before we look at number 11. So population density. This is not the mass of the people over their volume. This has to do with how crowded the area is. And so it's basically people, the number of people per square mile or per area. If you think of that, the unit should be people per square mile or per square foot or something like that, then it will help you adjust from mass divided by volume. This is really people over the area they live in. So that is a little change. You do want to make sure you cover that. And I would have them think about, what do you think they mean when they say population density? Is it the mass of all the people that live in California divided by their volume? What do you think that means? And so population density is actually the number of people divided by the area they live in. And so this problem 11 is a great problem to help understand why people would care about population density. Can I zoom in just a little more? Or maybe not. Maybe zoom in this way just a little bit more. And then I'll need to autofocus one more time. Okay, so the city of Clovis, actually it's number 12, pardon me. The city, the US 2010 U.S. Census said that Alaska had this many people, 710,232, and Rhode Island had just over 1 million people. This was the area of Alaska and the area of Rhode Island. So when they asked for the population density of Alaska, I took the number of people divided by the area in square miles, and I got 1.2 people per square mile. They got a lot of space in Alaska. They're not hitting elbows too often. Then for the population density of Rhode Island, I did my 1 million and some odd people divided by my 1,000 and some odd square miles, and I got 118 people per square mile. Much more crowded in Rhode Island than in Alaska. So that was interesting right there. That problem had stopped there, but it was even more interesting as we kept going. At the end of 2010, the total U.S. population was 308 million and some odd. If the entire population of the U.S. lived in Alaska, what would be the population density? And so I did the number of people divided by the area. So I used that 591,860, and I got 522 people per square mile. And so what I thought was, if we put the entire population of the U.S. into Alaska, it still wouldn't be as crowded as Rhode Island. And then, backwards, they asked, if Alaska had the same population density as Rhode Island, what would be the population of Alaska? So now I wanted to solve for population. So I took this density, 1,018. I should write my work down here because this was all my scratch work I wasn't planning on showing. So I have the density. See if I can make this right. Density equals the number of people divided by the area. And so if I want the population density to be 1018, I want to know how many people would that put in this area. And when I multiplied that over, I got 602,513,480. So almost double the population of the U.S. would have to fit into Alaska to make it as crowded as Rhode Island is. I thought that was an interesting application of population density. Number 11 is also about population density in Clovis, and so those are a couple at the end that are a little different. Okay, I hope you really enjoy this lesson. I did. I enjoyed teaching something a little bit different. That's always fun, and it wasn't very challenging. There was a couple spots where you might need to watch out that they need to use fractions. Oh my goodness, so terrible. And the rounding with pi. I usually had mine round to 3 decimal places, but it's your choice. They should be using calculator on this. So there you go. Have fun with it and good luck.